Hello and welcome. So, it says given the lengths of the circle below, solve for x. Alright, so we have chords and some lengths in said chords, right? We're told that we have this length of 5, that one 10, 2x plus 7, 3x minus 1. Now, how do we tackle this? Where are we going to go from here? Well, you have to know some of your properties with chords, right? And that is that we have what's this called proportional lengths when it comes to intersecting chords. That means that essentially the small length times the larger length of one chord is going to equal the, I'm going to call it of chord 1, sure, right, equals the small length times the larger length of chord 2. So, for example, right, let me put this into perspective. So, if you can't really see which one's the smaller or larger, it doesn't matter because you're multiplying, right? If you do 2 times 3, isn't that the same thing as 3 times 2? Yeah, it is. Okay, so don't worry too much about which one's smaller, which one's larger. As long as you just pick the right numbers, you're good to go, right? So, smaller length, 5, okay, times your larger length, 2x plus 7, okay? And that is of your first chord. So then that's going to be equal to your smaller length of the other chord, which, I'm going to call that 10, equals the larger length of the other chord, and that's going to be your 3x minus 1, and that is the property here. So you take the small length times the larger length equals the small length times the larger length. And that is a property of intersecting chords. Okay, and once you know, like, honestly, it's not too hard of a property. Okay, the hardest thing is remembering when you have this property is, and how to use it, right? Once in anything geometry, the hardest part is coming up with the relationship. Okay, and for intersecting chords with lengths, this is that relationship. Okay. And then from here, we're just solving for x. So right now we have 5 in parentheses, 10 in parentheses. These parentheses are doing you no favors. If your goal is x equals, you want to get x out of the parentheses. So you want to distribute these numbers through. So we get 5 times 2x, 10x, 5 times 7, 35. 10 times 3 is 30, so 30x minus negative 1 times 10, that's going to be negative 10. Now, if you want all of your x's alone, right, you want to solve for x, I'm going to move my 10 to the other side. The reason why I'm subtracting 10 and not 30 is because of personal preference. I like having my x's positive, right, because 30 minus 10 is 20x. That is a positive number. Okay, and on the same breath, I'm also going to add my 10 over. Right, if you want all of your x's to one side, you want all of your numbers to the other side. So if we have subtract 10, undo subtraction with addition, add 10 to both sides. Okay, now we have 35 plus 10, that is 45. So now we have 20x equals 45. How do you finish getting x alone? Well, divide, right? It's being multiplied by 20, so divide by 20 and you are good to go. So then we have x equals 45 20ths. Now this is a correct answer, right? But it's not just asking for a correct exact answer, it's asking for a correct simplified exact answer. Look at this fraction and tell me, is there anything here that simplifies? Yes, is the answer to that question, because 5 is the common number to both top and bottom. 5 goes into 45 9 times, into 24 times, and thus 9/4 is your fraction. And that's totally simplified, nothing more that can happen, and you're done, right? You just have to do one last double check, right? If you plug in 9/4 to your x's, are you going to get back negative lengths? No, not in this case, you won't, right? 3 times a positive number, specifically 9/4, that's a number larger than 1. If you subtract 1 to a number larger than 1, it ain't negative. You're good to go, right? Adding a number to a positive number, that's not going to make it negative either. Right? You're good to go. 9/4, box it, done. Okay? Not too shabby. Thanks for watching.